Okay, welcome Math 96 students. So these are our online lectures. We're starting where we left off in 10.6, solving radical equations. So we have two things to talk about in this section. The first is we need to be able to solve equations. Equations that contain a radical, or we're going to say that contain radicals. Sometimes they can have more than one. And the second thing is we're going to look at the Pythagorean theorem. And some problems with the Pythagorean theorem. So for this first example, we're going to walk through, or I'm going to walk through step by step, and we're going to list out the steps similar to what we did when we were solving systems of equations, so that you have a template moving forward. So we're going to solve the equation. And that equation is going to be the square root of 2x minus 3 plus 6 equals 15. So first step, every time, is to isolate the radical. We want to get it all alone on one side of the equation. So we're going to isolate the radical. So in this problem, that means moving the 6 to the right by subtracting it. So if you minus 6 on both sides, we end up with the square root of 2x plus 3 equals 9. So now the second step, once you have your radical all alone, is to raise both sides of the equation. Raise both sides of the equation to the power of the index. The index. So for our case, our index is 2 because this is the square root. If you have a cube root, you'd raise both sides to the third power. If you had a fourth root, the fourth power, so on and so forth. And the idea being, when we, in this case, square this, 2x plus 3 squared equals 9 squared. So it's a good habit to put both sides of your equation, because it's not always just going to be a 9 or a number over here. Put both sides in parentheses and then square the parentheses, so you're making sure that you're not mis-evaluating each side. But since we are squaring the square root here, we know that that's going to cancel, and we're going to have 2x. Well, that leads us into step 3, which is simplify. But we know here we're going to have 2x plus 3 on this side, because our square root and square power cancel, and this is going to equal 81. And then we can move the 3 over, and we have 2x equals 78. That's how subtraction works. And then we divide by 2, divide by 2, and we get x equals, what, 2 goes into 7 3 times, 39. Now, because it's a radical, we have to go back and check. So step 4 is to verify or check your solution. So we're going back in to the original equation here, and that original is the one that we were first given, way up here, not any of the adjusted ones that we have. So we have the square root of 2 times 39 make that plus 3. I realize now that it was a minus 3, and I made it plus 3 for some reason. So we'll just change it to plus 3. Won't change the process. That's not a big deal. So square root of 2 times 39 plus 3 plus 6 should equal 15. So this gives us the square root. 2 times 39 is 78. Plus 3 plus 6 should equal 15. I will make sure that I am writing bigger. 78 plus 3 is 81. Square root of 81 plus 6 equals 15. We know that this is 9 plus 6. And that definitely equals 15. So we know we have a solution, and we can box that number up. So these are the steps that you want to be following. No matter what index radical you have, you want to start by isolating your radical, then raise both sides by whatever your index number is. Once you've done that, you're simplifying until you get to a solution, then you have to go back and check. You just have to. There are going to be what we call extraneous solutions, just like we saw with the systems of equations. Sometimes we solve the equation and it doesn't work. And the reason you get those extraneous solutions because of the squaring here. We are altering. That's not a word. Is it? I can't tell. We are changing the equation by squaring both sides. Now, by squaring both sides, we've kept equality, but it doesn't mean that we don't force some fake solutions, so to speak, those extraneous solutions that I was talking about. So for these video lectures, obviously I can't have you do practice problems, and I can't walk around and help you. But you should be, aside from this one, when I tell you, and I'll try and remind you as best I can, to pause the video and try. So now that you've seen the process, this next example that I'm going to work through is to solve the cube root of negative 10x minus 1 plus 3 equals 0. So you should pause the video here and try and follow the steps in the last problem that we outlined. Isolating the radical, raising both sides to the power of the index, simplifying, and then checking your solution. So pause it and try it out. I'm going to walk through the solution now. So if you're watching this, hopefully you paused and tried. So isolating the radical, we have the cube root of negative 10x minus 1 equals negative 3. I'm going to raise both sides to the power of 3. I'm going to get negative 10x minus 1 equals negative 27, which is negative 3 cubed. I'm going to simplify a little bit. Plus 1 here, plus 1 here. Negative 10x equals negative 26. Divide by negative 10. And we get x equals positive 2.6, or 13/5. I think I'm going to leave it as 13/5 for the simplification. So this is not the end, though. We now need to do our check. So I'm going to go back to the original over here, and I'm just going to split this up. So this was my solution. Over here is going to be my work check. So I have the cube root of negative 10 times 13 over 5 minus 1 plus 3 should equal 0. So inside the cube root here, negative 10 over 1. This is going to cancel with the 5, and this is going to be essentially negative 2 times 13, which is negative 26, minus 1 plus 3. So we have the cube root of negative 27 plus 3 should equal 0. Cube root of negative 27 is, of course, negative 3. Remember, our odd index radicals can absolutely have negatives in the radicand. So negative 3 plus 3 definitely equals 0. So this is our solution, 13/5. Okay, so the next problem is kind of upping the difficulty a little bit. we're going to look at solving equations that have multiple radicals. So we're going to solve the square root of 2x plus 5 plus the square root of 2x equals 3. So when you have two radicals, you need to start with one and eliminate one at a time. So the first thing I'm going to do is move one of these two radicals to the side with the 3, so I can just solve for one of them. And I'm going to move that square root of 2x over. So now I have the square root of 2x plus 5 equals 3 minus the square root of 2x. And we're doing this because now I can follow our steps. I'm going to square both sides. And again, I encourage you to write your parentheses before you put your power so that you know how you're squaring things. So on this side, the square root cancels, and we have 2x plus 5. And over here now we have to FOIL it out or use our perfect square trinomial technique. So 3 squared is 9. And then it's going to be plus 2 times this, which is minus 6 square root of 2x. And then plus this squared, which will be plus 2x. So we're going to simplify. I'm going to move the 9 and the minus 2x over. These cancel, these cancel, these cancel. We have negative 4 equals negative 6 square root of 2x. Now notice we're right back to where we were in the last two examples. We have our radical on one side. So I'm going to divide by negative 6 to isolate the radical. So we have 2 over 3 equals the square root of 2x. And now we're just repeating the same process we started with. We're going to square both sides to undo that square root. And we're going to get 4 over 9 equals 2x. Divide by 2, divide by 2. And you can think of this as 4/9 divided by 2 over 1. So we end up with x equals, so flipping and multiplying, 1/2 times 4/9 is 2/9. And I boxed this a little prematurely. We have to go back and check. So we have our solution is 2/9. I need to go plug it back into the original equation now and double check that it works. So again, I'm just going to do this over here on the right. So the square root of 2 times 2/9 plus 5. I realize that is very small. 2/9 is what I'm plugging in there. Plus 5 plus the square root of 2 times 2/9. This should equal 3. So we have the square root of 4/9 plus 5 as a fraction over 9 will be 45 over 9. And then plus the square root of 4/9. This should equal 3. So we have the square root of 49 over 9 plus, I can evaluate this, 2 over 3. So this is not a decimal, ignore this. This should equal 3. The square root of 49 over 9 is 7 over 3 plus 2 over 3 should equal 3. This is 9 over 3, which definitely does equal 3. So we have our solution. So that's how we take care of equations with two radicals. You just do one at a time, isolate one of them, make sure you undo that radical. In this case, it was a square root. Then you simplify as much as you can until you get back to another isolated radical. Undo that one by the proper power And if you have 2, you should only have to do this twice. If you have 3 radicals, you'll have to do it 3 times, and so on and so forth. And then make sure you're checking your work to make sure your solution is a true solution. Okay, so I have 3 solutions or 3 problems that I would have given you to practice. So solve the following. The first is the square root of 3x minus 5 equals 7. Then it's the cube root of x minus 2 plus 1 equals 3. And then the last one is the square root of 6 plus x equals the square root of x minus 4. So these were supposed to be practiced, so please pause the video and try these out. Follow the steps, and I'm going to start working through them now. So we need to square both sides here to undo this square root. We have 3x minus 5 equals 49. Adding 5 over, we get 3x equals 54. Dividing by 3, we get x equals 18. Now I will leave it up to you to check your work. Over in part B, we need to isolate the radical. So we have the cube root of x minus 2 equals 2. We then cube both sides, and we get x minus 2 equals 8, or adding 2, x equals 10. Again, I will let you verify and check your work, and you do need to practice checking your work, plugging your solution back into the final, or into the original equation. So moving on to C, our radicals are already isolated for us, 1 radical on each side. So I just think it's easier to go with the one that's already isolated and square both sides. Excuse me. So the square root squared undoes itself. And we're just going to have 6 plus x on the left. And on the right, again, it's perfect square. So we're going to have the square root of x squared is x. And then it's going to be plus 2 times this times this. So that's plus 2 times negative 4 is minus 8 times the square root of x. And then plus 16 for negative 4 squared. And then we simplify as much as we can. We're going to minus x minus 16, minus x minus 16. And we get cancel, cancel, cancel. Negative 10 equals negative 8 square roots of x. Divide by that negative 8. And we get 5 over 4 equals the square root of x. Square both sides. And x will equal 25 over 16. And again, I will let you verify, and you should verify this. So, there's a good amount of practice there that we've gone through solving radical equations. The last thing in this section is we're going to talk about the Pythagorean theorem. Scoot that up a bit. So we've seen the Pythagorean theorem before. We mentioned it briefly last week. Pythagorean theorem. It's probably one of, if not the best known mathematical theorem. And this is always for right triangles. So for a right triangle that has the form A, B, and C. So the legs of the triangle are A and B, and the hypotenuse is C. Pythagorean theorem says that we can find the lengths of each of these using this equation. A squared plus B squared equals C squared. And so a lot of times this is the Pythagorean formula. And again, it's only for right triangles. Now, we talked about this last week when we did distances. And the reason for that is, let's say we were finding the distance between 2 points here and here, the vertices attached to that hypotenuse. Well, we can find that by finding the value of C. And if we square root both sides, we get C equals the square root of A squared plus B squared. And that's how we could find that. Now, the distance here, this is the difference in x's. So if this is our point and this is our point, this distance B would be what we saw in the distance and midpoint formula section, x2 minus x1 from here to here. And the distance A that's getting squared would be the difference between the y's, y2 minus y1. So that Cartesian distance formula is nothing more than the Pythagorean theorem, just in a little different form. So let's look at two examples of Pythagorean theorem. So given this triangle, x, 5, and 13, we are going to solve for x. So this is the classic Pythagorean theorem question. You're just applying the theorem. So since our hypotenuse is the 13, 5 squared plus x squared has to equal 13 squared. And so we have 25 plus x squared equals 169. Subtract the 25 over and we get x squared equals 144. Square root, square root. Square root of x squared is x equals 12. And that's our answer. Easy peasy. The next one is slightly more challenging. So now that we've seen this problem, I would like you to try this one after I'm finished writing it by pausing the video. So solve the triangle. Now, when you're told to solve a triangle, it means some very specific things. The big thing is it means at minimum find the lengths of all the sides. Pretend I can draw triangles, which I cannot. So here are triangles x by x plus 1 by x plus 2. So when you're told to just solve the triangle, you need to list the three sides. So ultimately we're going to be finding x, but we need to find what x plus 1 and x plus 2 are. And this is Pythagorean theorem. So as I said, please pause the video and try this one out. I'm going to start working through it now. So our Pythagorean theorem says x squared plus the other leg, x plus 1 squared, should equal x plus 2 squared. We have to expand this out, so we have x squared plus x squared plus 2x plus 1 should equal x squared plus 4x plus 4. So these are just coming from expanding these out, either foiling or using our perfect square trinomial formula. And then we'll collect like terms. So we have 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. I'm going to move all of these terms to the left. Subtract them away. Minus 4x minus 4. So we have x squared minus 2x minus 3 equals 0. And so now we're thinking what multiplies to make negative 3 and adds up to negative 2. And that's going to be negative 3 and positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. And that equals 0. That means x equals negative 1 or x equals positive 3. So now because of this, again, this is why we want to check our solutions in these problems. We know that this is a triangle. It has a distance. And so all you have to do is ask yourself, can your distance ever be negative 1? And the answer is no. We can't have negative distance. Right? We've talked about this a couple times in our application questions. Can't have negative distance, can't have negative time. So we throw that solution out, and we have our final answer is x equals 3. So the sides of our triangle, again, pretend I can draw triangles, would be 3, 4, and 5. And now the triangle is solved. Okay, so that is the end of 10.6. And I won't see you. You'll hear me in the next lecture.